Hello everyone. In this video, I am going to simplify one problem in the topic convolution. Now, here is the question. Find the convolution of x1 of t and x2 of t for the following signals. Now here, x1 of t signal is a e power minus at into u of t, and x2 of signal is e power minus bt and u of t. Here, the given x1 of t and x2 of t, both the signals are continuous time domain signals, and e power minus at means nothing but it is a decaying exponential signal multiplying with step signal. When we are doing the product of these two signals, we may get definitely the decaying exponential signal only. Now here we are going to do convolution of these two signals, and at the end we are going to find the output signal y of t. Now here are the figures regarding x1 of t and x2 of t, and we know the graphical convolution and we solved so many problems in previous videos. So here I am going to represent both the signals in step 1, nothing but we are going to represent both the signals with independent variable tau. Now this is the x1 of tau signal, this is x2 of tau signal, and then we need to find out the reversal of one of the signal. Here I considered x2 of tau, and regarding that x2 of tau reversal signal is going to be x2 of minus tau, and then by considering a large negative time shift, we are going to draw in the second quadrant this respective signal. So this is the x2 of t minus tau signal, and this is the x1 of tau signal, and both the signals we drawn on same tau axis. And by moving these x2 of t minus tau signal towards right side, if there is any overlapping period in between these two signals, in that overlapping period, by considering common integration limits, we are going to find out the output signal y of t. Now here we moved the x2 of t minus tau signal towards right side. Here we found the overlapping period. In this question, there is one important thing. Here, the given both the signals x1 of t and x2 of t, both the signals are causal signals. Nothing but a signal x of t is said to be causal if x of t equal to 0 for t less than 0. Means here in these two figures, it is showing that x of t equal to 0 for t less than 0. Nothing but in negative time instances, the x of t signal is going to be 0. So here these both the signals are causal signals. So when we are doing convolution of causal signals, definitely the integration limits are going to be 0 to t. And here one thing we have to observe that if both the signals mathematical expressions are going to changing or not. If mathematical expressions are not changing in overlapping period means definitely the integration limits are going to be 0 to t for given causal signals. So here, now in this case, both the signals x1 of t and x2 of t are causal, and we are going to do the convolution of x1 of t and x2 of t. This is the principle we are going to use, and by considering x1 of tau mathematical expression, this one, and x2 of t minus tau mathematical expression, this one. Here u of tau and u of t minus tau is going to be 1 because it is a unit step signal. And by considering these exponential expressions, if we are simplifying this integration, this is the output we are going to find. Y of t is equal to e power minus at minus e power minus bt divided by b minus a into u of t. Means here this is the output signal which is going to be, we are finding for t greater than or equal to 0. So that is why we are multiplying the output signal with u of t. So this is the procedure we have to follow when we are doing convolution of given two continuous time domain signals And if these given signals are causal limits, definitely the integration limits are going to be from 0 to t. And in the description box, I am going to provide two more questions based on causal signal convolution. You try to solve those problems and send me the answer to comment box. Your comments are very valuable to me.